Very good morning, students. Today we discuss about the electrical machines. And the first we have discussed about the DC motor. In the part of electrical machines, the DC motor definition, construction of, and working principle of the DC motor. Basically, DC motor is an electromechanical energy conversion device that converts a direct current electrical energy into mechanical energy based on the principle of current carrying conductor placed in a magnetic field experiences as a force. The direction of rotation is determined by Fleming's left hand thumb rule, and the magnitude of torque depends on there are three major particles, that is the major parts: magnetic flux, armature current, and number of conductors in a values. So here the working principle of a DC motor is based on the fundamental law of electromagnetism. When a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. This force is described by the Lorentz force law, and its direction is determined using Fleming's left-hand thumb rule. According to the Fleming's left-hand thumb rule, the Lorentz force law, the force equal to magnetic flux into current carrying through the conductor into length of the conductor within the magnetic field. That can be given to the F equal to BIL. This is the major working principle of the DC motor. A DC motor is an electrical device that converts electrical energy into mechanical energy. A rotary component called an armature coil rests inside the motor's casing surrounded by the strong permanent magnets. When a current is applied to the armature through a rotary electric switch called a commutator, the magnetic field created by the armature interacts with the magnetic field of the stationary magnet to apply a torque on the armature, causing it to rotate. The DC motor diagram here, whenever you have to see the diagram of the DC motor, it consists of a armature, the yoke, field windings, and carbon brushes, and the commutator. The basic working principle of a DC motor is that whenever a current carrying conductor is placed in a magnetic field, it experiences a force. The force is known as the Lorentz force equation. I'm already discussed in the earlier slide. It is responsible for the rotation of the motor's armature. The middle finger indicates, like left hand thumb rule, the middle finger indicates direction of the magnetic field, and the index finger indicates direction of the current, and the thumb shows the direction of the force acting on the conductor. The magnitude of force can be calculated as F equal to BIL, Lorentz force equation. So the Lorentz force equation based on the Fleming's left hand thumb rule as shown in the figure. So coming to the construction of the DC motor, a DC motor has several important parts like the armature, commutator, brushes, field windings, and shaft. Each part plays a role in helping the motor turn electrical energy into a motion. These parts work together to make the motor run smoothly and effectively. Coming to the main part is the motor is starter. The starter is the DC motor's stationary component. It fixes one place. Its primary function is to serve this device solid out frame and generate the magnetic field. The starter's various components are described below. Though here, the next component is yoke. Yoke is the outer cover which provides the structural strength to the motor by acting as a frame. It is usually made of any low reluctance magnetic materials such as rolled steel, silicon steel, or cast iron. So coming to the diagram of the motor, so here there are two magnetic bars. Inside the magnetic field, you have to connect it to the armature. The armature is connected to the poles and field windings. Whenever you have to give into the supply to that one, automatically with the electrical energy converted to the mechanical energy. Poles and pole shoes. The pole shoe is fixed to the yoke of the motor casing with a pole shoe at the other end. Usually made of limited about the iron, a thin cast steel. The poles produce the magnetic field when excited by the field coil. The pole shoe is only a tiny air gap away from the armature. It is shaped in such a way as to maximize the magnetic flux that passes to armature. Coming to the field winding is the copper wire wound around the pole with the purpose of the generating magnetic field when a current is passed through it. Depending on the type of motor, the field winding can be connected in series in parallel to the armature. Next, armature core. It has a large number of slots to hold the armature winding along the periphery. The core is usually made high permeability and low reluctance material such as silicon steel. Armature windings. The armature windings are crucially for creating the magnetic flux of the rotor. Now, finally, commutator. The commutator is mounted on the motor shaft and connects to the armature winding. It is made up of segments of hard driven copper insulated from one another with mica. Its function is to convert torque that alternates to the unidirectional torque on the armature. So,